Okay, so what we're going to work on today is the fundamental theorems of algebra. So I'd like you to work on the try this and then come back and check your answers. Okay, so let's see what we have. It says to first determine the degree of the polynomial and then to factor. So remember, the degree of the polynomial is its largest exponent. So I see here for number 1, I have x squared minus 6x plus 8, so my largest exponent is 2. So that would be the degree. So I have a degree of 2. Okay, so now let's factor. So I'm going to use master product. So when I multiply the first times the last, I get positive 8x squared. Okay, so now I need two numbers that multiply the 8 and then add to 6. That would be 4 and 2. So that is 4x and 8x. Oh, 2x, sorry. And they will get the same signs. They're both going to be negative, and that's how I get my negative 6x and bring down the positive 8 at the end and the x squared at the front. And then we will factor by grouping. So the GCF of the first group would be x times x minus 4. And then the GCF of the second group would be negative 2 times x minus 4. So my factors are x minus 2 and x minus 4. Okay, so I'm not really sure what's going on with the stylus today, why it's not working too well, but let me see what happens. All right, so let's take a look at number 2. All right, so I noticed with number 2 there is a GCF, so I'm going to factor out the GCF, which is x. So that is x times 2x squared minus 5x minus 12. All right, so now I'm going to use master product. So I get, when I multiply the first times the last, I get negative 24x squared. So what multiplies to 24 minuses to 5 would be negative 8x and positive 3x. And then I bring down the negative 12 and the 2x squared. And then I factor by grouping. I really do not know what's wrong with this today. So let's group here. So the GCF of the first group would be 2x times x minus 4. And the GCF of the second group would be 3 times x minus 4. So my factors are 2x plus 3 and x minus 4. And then remember we have this x here. So what we want to know from this, the reason why I'm reviewing this, is because it's these here. These are called, so hopefully you're writing this all up here. These are called linear factors. So write that down, linear factors. And the reason why they're called linear factors is because if you graph each one of these are all lines. Okay, they have their first degree. So they're all called linear factors. Okay, so there's a few things about the fundamental theorems of algebra. The first thing is to be able to identify the number of roots you will have. So the number of roots you will have is indicated by the degree. So that's indicated So that's indicated by the degree. So if the degree of the polynomial is 4, that means you will have 4 roots. Doesn't mean that they're all real, but you will have 4 roots. You could have 2 real roots and 2 imaginary roots or 2 complex roots. The number of factors is also indicated by the degree. So that says indicated by the degree. So if your degree is 5, you will have 5 factors. And the last thing is how many maximums or minimums will you have? It's always the degree minus 1. So if your degree is 7, you will have 6 maxes or minimums. All right, so let's look at the examples. Okay, so what it says to do is determine how many roots, factors, and relative max minimums each polynomial have. All right, so let's take a look at number 1. I notice for number 1, my degree is 2, so that means it will have 2 roots. It will have 2 factors. And it'll have 2 minus 1, which is 1 min or max. All right, let's take a look at number 2. The degree is 5, so it will have 5 roots. It will have 5 factors. And it will have 5 minus 1, 4 maxes / mins. Okay, so let's take a look at number 3. Now, number 3 is in a factored form. So I have to think of this. If I multiplied that out, I would get an x to the squared in there. And that's times an x to the third there. And the same thing here. If I multiply that out, I'll get another x squared. So when I multiply my x to the third times x squared, I actually get an x to the 7th power. So my degree here is 7. So therefore, I will have 7 roots. I will have 7 factors. And I will have 7 minus 1, so 6 mins / maxes. Okay, so now let's take a look at representing a polynomial equation with linear factors. All right, so let's take a look at what we have to do. We have to solve the polynomial. We're going to write each solution as x equals. Then you're going to get each solution to equal 0, and then you're going to write as factors. All right, so let's take a look at number 1. So I have x squared minus 2. So we're going to solve this. So what I could do is I could add 2 to both sides. So I get x squared is equal to 2. To get rid of the square, I could square root both sides. So I get x is equal to, don't forget the plus minus, the square root of 2. So these are my roots. X equals the square root of 2, and x is equal to negative the square root of 2. So now what you want to do is get these to equal 0. So I'm going to minus the square root of 2 from both sides. So I get x minus the square root of 2 equals 0. Add the square root of 2 over here. So they get x plus the square root of 2 is equal to 0. Those are your factors. So my factors are x minus. My factors are x minus the square root of 2 times x plus the square root of 2 equals 0. So notice these are my linear factors. My linear factors happen to be irrational, right? So they're complex. All right, so let's take a look at number 2. All right, so number 2 is x squared plus 4 is equal to 0. So I'm going to subtract 4. So I get x squared is equal to negative 4. I'm going to now take the square root of both sides. So I get x is equal to plus minus 2i. So my roots are x equals 2i and x equals negative 2i. So on the left, now I need to get these to equal 0. So I minus 2i. So I get x minus 2i equals 0. And on the right, I add 2i. So I get x plus 2i equals 0. Sorry, that was a funky eye here. And now those are my linear factors. So my linear factors are x minus 2i times x plus 2i equals 0. All right, let's take a look at number 3. Okay, so number 3 is a trinomial, so I'm going to use master product to solve this. And when I use master product, I multiply the first times the last, and I get negative 80x to the 4th. So what multiplies to 80 and minuses to 16? That would be 20x squared and 4x squared. So that's 20x squared and 4x squared. They get different signs. 20 will get the positive, so that means I get my positive 16. So I bring down the 80 and bring down the x to the 4th. And then I'll factor by grouping. So the GCF of the first group is x squared times x squared plus 20. And the GCF of the second group is negative 4 times x squared plus 20. So my factors are x squared minus 4 and x squared plus 20 equals 0. Okay, so now this here on the left, this can actually be factored again. That's the difference of two perfect squares. So that's x plus 2 and x minus 2 equals 0. So my zeros are x, or my roots are 2 and negative 2. All right, on the right over here, I have x squared plus 20 equals 0. So minus 20, I get x squared is equal to negative 20. Square root both sides. So I get x equals plus minus I the square root of 20. Now I want to simplify the square root of 20. The perfect square that goes into 20 would be 4. 4 times 5. And then the square root of 4 is 2. So it would be x equals plus minus 2i, the square root of 5. All right, so then my roots are x equals 2i, the square root of 5. And x equals negative 2i, the square root of 5. Okay, so let's see here. Okay, so now these are my linear factors here. So I have x plus 2x minus 2, x plus 2, x minus 2. And then these here, I have to subtract 2i, the square root of 5. So it'll be x minus 2i, the square root of 5. And this one here, I'll add 2i, the square root of 5. So it'll be x plus 2i, the square root of 5. And just squeeze in there equal to, just squeeze at the end, equals to 0. Okay, so let's take a look at the last one. Okay, so the last one is x squared minus 4x plus 2 equals 0. Now, I'll tell you, you could try to do master product, but master product doesn't work. Okay, so I have to solve this either using completing the square quadratic formula. So I notice here that I do have a leading coefficient here of 1, and my middle term is even, so I'm going to complete the square. So I start off by minusing 2. X squared minus 4x is equal to negative 2. So now I do half of negative 4, which is negative 2. Squared is positive 4. Add that to both sides. I get x squared minus 4x plus 4 equals negative 2 plus 4, which is 2. And then I factor this side. I get x. And x, remember, the number that goes in your parentheses is what you got when you did half of your b here, which was negative 2. So I have x minus 2 squared is equal to 2. All right, so square root both sides. I get x minus 2 is equal to plus minus the square root of 2. Add 2 to both sides. So I get x equals 2 plus minus the square root of 2. Okay, so I just need to move some stuff up. Okay, so my two roots right now are x equals 2 plus the square root of 2 and x equals 2 minus the square root of 2. All right, so this guy on the left, I'll minus 2 and minus the square root of 2. So it's x minus 2 minus the square root of 2 equals 0. And this guy here, I'll minus 2 and add the square root of 2. So it's x minus 2 plus the square root of 2 equals 0. So my factors are x minus 2 minus the square root of 2, x minus 2 plus the square root of 2 equals 0. Those would be my linear factors. Okay, so that's it, and you have a homework that you are going to hand in for me at the end of the week. Okay, so have a good night, and if you have any questions, then ask me in class tomorrow or, obviously before your homework is due. Okay, have a good night, everyone.